Hi guys, in this video I will be explaining the GeeksforGeeks problem called generate binary numbers. So we are given with an integer n. We are supposed to return the binary binary integers until n. So how we can calculate the binary number is let let us take n as 7. Wait, let n be 7. So for n 7, at first we need to divide the given number by 2. So we can divide the 7 by 3, which will get 6, and we will get 1 as a reminder. Let's store it into a string 1 here. Now, sorry, this is not good. 3. So now we need to divide this 3 by 2 again. 2 1s are 2. So when we divide this 3 by 2, we will get 1 as a reminder. We'll add it here. So we can't divide 1 by 2. So we will add this 1 to string. So whatever we got, we need to reverse this number. 1 1 1 reverse will be 1. Similarly, let me take another example. Let's take 9 this time. So when we divide 9 by 2, and 2 4s are 8, so we'll get 4 here. And for string, we will add 1 as a reminder. So we need to divide the remaining thing by 2. Remainder is 0. When we divide the 2 by 1, we will get 0 as a remainder. And the last one will be added to string. So if we revert this number, we'll get the same thing only. So how we can confirm is, let me start doing the indexing here. 0 1. So in order to convert a binary to decimal, we need to start indexing from right side, 0 1 2 3 like this, and we need to add them like 2 powers, 2 power 0, 2 power 1, 2 power 2 square, 2 cube. So 2 cube is 1, so we need to add 2 square is 2 square is 4, but here it is 0, so we should not add. 2 power 1 is 2, but here it is mentioning as 0, we should not add. And 2 power 0 is 1, and the decimal value is 1, we should add. That equal to 9, which is nothing but the number which we took here. So let me implement the Python solution for this. So as we are supposed to generate the binary numbers from 1 to n, I will take a for loop here for I in range of 1 comma n plus 1. So I will take a list here to store the values, and I will add it to the answer that append of. I will write a function named binary, which will return the binary string of the number, and at last I need to return the answer. Now we need to implement this binary function. Binary, it will take the input n. So what we need to do, we need to take a string. So while n not equal to 0, at first we need to add the remainder when the particular number is divided by 2. So answer plus equal to str of n mod 2. Wait 1 minute. N mod 2. So what n mod 2 does is, it will divide the number, it will get the remainder when the number is divided by 2, and we are converting it to string, as we are supposed to store it in a string variable, and we need to divide the n by 2. At last we are supposed to return the reverse of the string obtained. Remember, as I shown in whiteboard, we need to reverse the string which we obtained at last. Let me compile and check for the sample test case. Mhm. Mm, Sorry, here I need to send the parameter as I, not n. Yes, it's passing the test case. Yes, it is passing all the test cases. And we can also replace this code with a built-in function in Python, which will return the binary of an integer with and takes the input n. So return bin of n. So bin of n returns the hash code. We need to let me show the output also. So bin of n returns a binary number along with some extra 0b, adding 0b to it, representing it as a binary. So when we do 2 colon indexing, which will take this thing only. So we need to add a for loop here for I in range of 1 comma n plus 1, answer dot append of. So here this bin function is built-in function in Python, which will calculate the binary similar to our custom function. And again I passed in here, not yes, it's passing successfully. Thanks for watching.